Hello students, today we will learn about beams. It comes in your unit 3 of engineering mechanics, right? So before finding beam reactions, you need to know some basic concepts behind it. So let's start with these five concepts. So first is we will learn about flexion, then types of support, types of beams, types of loads, moment, and couple. Right. So let's start with flexion. So what is flexion? Suppose you have a horizontal member. The member is horizontal, and loads are working perpendicular to it. Right. So this effect will create two phenomena. One is shear and the second is bending, right? So what is shear? Shear is simply action that a scissor makes on the paper, right? So it will cut the paper or tear the paper. So it is called shear, shearing a member. So when a force acts perpendicular to the axis, it will tear it or shear it. So first possibility is this. Second is bending. So this member will be bent due to these loads. Right? So whichever member carries loads perpendicular to the axis, right? Whichever member carries loads perpendicular to its axis is called flexure member, and beams are flexural members. Now beams are not only in the buildings. Wherever you see this phenomenon, where the axis and the loads are perpendicular, you can call that flexure member or a beam. It may come in some machine parts also, right? So that is basically flexure, and beams are flexure members. Now, to understand beams, we first need to understand supports. So we will cover three types of support here. First is simple support. Okay, first one is simple support. A simple support is drawn like this. You make a triangle, you do hatching here, and there is a beam somewhere. Right? So simple support is pin jointed at the top. It is pin jointed at the top. Pin means you consider it like a hinge. So whenever you apply vertical force here, like vertical force, then it has fixity here. So fixity does not let it move downwards. So it will react upwards. So you are applying force downwards and it is reacting upwards. So this is first reaction of a simple support. Again, if you try to move this horizontally, means you apply a horizontal force this way, then it will react horizontally and apply this reaction. Okay. Now, if you try to rotate it, then due to the spin, it will rotate freely. Now, if it rotates freely, it does not resist the rotation. So there is no rotational reaction here. So simple support has two reactions, one vertical and second horizontal, because it is restricted in vertical and horizontal direction. It is free to rotate. Right. Next support is roller support. Next is roller support. Now roller support is similar to this simple support, but there are rollers here in the horizontal direction. Right. So when you try to move this downwards, you apply vertical loads, it will react vertically. It will not move downwards. But when you try to move it horizontally, it will go ahead, move due to these rollers. So it is free to move horizontally. That's why it does not give you a horizontal reaction. And again, here is a pin, just like simple support. So it is free to rotate and will not give you a rotational reaction. So this roller support has only one reaction, that is vertical. Now let's see the last one, that is fixed support. Right? Fixed support. Now, as the name suggests, fixed support is fixed in all the directions. Fixed in all the direction. That means if you try to move this vertically, it will give you a vertical reaction. If you try to move this horizontally, it will give you horizontal reaction. And if you try to rotate this, it will give you rotational reactions also, because there is no pin here. It is not free to rotate. So it will give you three reactions: vertical, horizontal, and rotational. Right. So we will consider these three types of support further in types of beams. First is simple support, which has two reactions. Roller support, only one reactions, and fixed support, which has three reactions. Right. Now let's move to types of beams. Now, depending on which type of support is on which end of the beam, we can decide type of beam. So, first we will see simply supported beam. First is simply supported beam. Right? Simply supported beam has one simple support and other side roller support. This is your typical simply supported beam. Now, how many reactions will this get? Two reactions. And here only one reaction. This is your simply supported beam. Second beam is overhanging beam. Okay. Second is overhanging. Overhanging beam is similar to simply supported beam, but it has some hanging portion. Right? This is your simple support, here roller support, and there is some portion of the beam hanging beyond this roller support, or it can also hang beyond this support on both side or any one side. These beams are called overhanging beams. Again, how many reaction? One, two, and three reactions, right? Next, we will see cantilever beam. Fourth one is cantilever. Third one is cantilever beam. Okay, cantilever beam has fixed support at one end and no support at other end. Okay, it is fixed at one end and it is freely suspended on other end. So how many reactions here? One vertical, one horizontal, and one rotational because this is fixed support. So three reactions here. Right now, all these three beams have three reactions. We will club these into a group and call them determinate beams. These all are determinate beams. What do we mean by this word determinate? That is, all three has three reactions, right? So, number of reactions are three. And how many equilibrium conditions do you have, right? Number of equilibrium conditions. Okay, number of equilibrium conditions here are also three. Which the equilibrium conditions do we have? You have one is sigma h equal to 0, other is sigma v equal to 0, and sigma m at a equal to 0, a or b any point. Sigma, that means moment at any one point will be equal to 0. Summation of moment at any one point will be equal to 0. So from these three conditions, you will find three equations, and by these three equations, you can solve three unknowns. These are your reactions. So these we might determinate because number of unknowns and number of equations are equal. Right? All number of unknowns are less than the number of equations available with us. So these three are uh, determinate beams, and in your syllabus you have to calculate examples for only these three determinate beams. That I'm talking about only diploma level, okay, engineering mechanics. So now let's see indeterminate beams. So fourth one is fixed beam. Okay, fixed beam is fixed at both ends. Fixed at both ends. So it has one, two, three reactions here. One, two, and three reactions here. Number of equilibrium conditions are only three, and total unknowns are six. So this beam is indeterminate beams. Right? That is fixed beam. Fifth one is continuous beam. Continuous beam is just like your simply supported beam, but it has more than two supports. Okay, more than two simple or roller supports. This is your continuous beam. This can go long, right? And sixth one is propped cantilever beam. Propped cantilever beam has fixed end at one and simple support or roller support at other end. This is your propped cantilever beam. Now again, number of reactions are exceeding three. Number of reactions are exceeding three. Here four reactions, and here one, two, three, four, then five reactions. So more than three reactions, we cannot calculate it with simple methods. So these are indeterminate beams: fixed beam, continuous beam, and cropped cantilever beam. These three are your indeterminate beams. So whenever the question is asked, explain types of beam, you have to group them into two parts. One, three beams are determinate and three beams are indeterminate. Right? Let's move on to types of load. Okay, loads. So first is simply point load. Okay, first one is point load. How do we show it? So at any point on the beam, load X. This is called simply point load. You call the value as W. This is point load, value is W. Second is UDL. Full form is uniformly distributed load. UDL. Now, as the name suggests, it is uniformly distributed over an certain length. So, suppose this is length L, then this load is W kilonewton per meter, right? Newton or kilonewton per meter. That means W is the intensity of load and it is distributed over length L. Now, if you need to find value of this UDL, so value total load of this UDL will be W into L. And where is the location of this UDL? It is in the center, right? L by 2 from here and L by 2 from here. So if you need to find location of this UTL, you just concentrate all the load at the midpoint and uh, we can assume that it is acting at this midpoint. Okay. So this is UDL and third one is UVL. Again, this is only for theory purpose, this uniformly varying load. This is, you don't need to calculate the examples of UVL for our subject. Right, so UVL acts like it starts from 0 and goes to intensity W. Okay, uniformly vary. It uniformly varies from 0 to W over the length of L. Now again, the value of this UVL will be the area of this triangle, that is WL by 2. And where is the location of this? It will be at the center of this triangle, that is L by 3 from here. And if you have to calculate from here, it will be 2L by 3. This is only if a question is asked, explain types of load, you need to explain all these three, right? You don't need to calculate examples of this UVL. We will calculate examples based on point load and UDL. Now, before moving forward to the examples, let's understand one more concept, that is moment. Okay, what is a moment? Now, when a load acts uh, far from our point of application, if we want to see effect of that force on that point, you need to calculate this moment. And moment is force into distance. Now, suppose this is my point of application and the load acts here. Okay, the load is uh, load say P and this distance is X. So moment of this load at this point is P into X. And how to consider direction of this is uh, you just extend from this arrow and take it to our point and see this rotation. This is clockwise. Clockwise is positive. Okay. Clockwise moment is positive moment. Now suppose you have application point here and load is going this way. P into this is X. Now this force X anti-clockwise. Okay, anti-clockwise is negative. Anti-clockwise is negative. So this is how you calculate moment. The formula is F into D and direction is decided upon whether the rotation is clockwise or anti-clockwise. And what distance do you take? The distance is distance taken is the minimum distance. That will be perpendicular distance. So this P and X should always be perpendicular. So if the force is vertical, distance is horizontal. If force is horizontal, distance is vertical. And here remember that line of action of a force is extended infinitely, okay, beyond this arrow. So this is how we calculate moment. One more thing here is couple. what do you call a couple? So if two forces acting simultaneously both have equal in value, right? Equal in value, opposite in direction, and parallel to each other. Then these two forces create a couple, and the value of this couple is force into distance between them. So if distance between these two is A, then the value of this couple is B into A. Now, couple can also be clockwise or anti-clockwise. This couple rotates clockwise, so we will take it as positive. If we have a reverse couple, it is acting like this. Now this rotation is anti-clockwise, so that will be negative couple. So you need to understand this much before trying to solve examples of beam reactions. So in next video we will see some numericals. Uh, Before jumping there, I recommend you watch this one first. Right? Thank you.